Assalamu alaikum kids. Inshallah, in this video we'll discuss the quantities required to study kinematics, which is the study of motion or moving objects. So motion can be categorized in various different ways. We can have objects that are stationary, can be said that the objects are at rest, or we can have objects that are moving. The objects that are moving can be further divided into objects that are either moving at constant speed or velocity, or objects that are accelerating. And now we'll take a look at 5 different quantities that we usually use in our physics course to define motion. So the first two quantities that we'll look at to define motion are distance and displacement. What is distance? Distance is the length of the total path taken by an object. It's a scalar quantity, while displacement is the shortest or the straight line distance between 2 points. It's a vector quantity. So let's take a look at an example which will help us differentiate between distance and displacement. Let's assume an object moves from A to B, 8 kilometers east, and the same object goes from B to C, 6 kilometers north. It's very easy to figure out the distance. The distance is the length of the total path taken, which is going to be 6 plus 8 kilometers, so that's a total of 14 kilometers. But the displacement is going to be different. The displacement is going to be from A to C. So the direct length from A to C is going to be the displacement. To figure out the displacement, we are going to use the Pythagoras theorem, which is hypotenuse squared is equals to the sum of the squares of the two legs of the right triangle. In this case, we have 8 kilometers east and 6 kilometers north. And as discussed in the previous videos, your north and east have an angle of 90 degrees. Hence, A, B, and C will be a right angle triangle, where we can easily use the Pythagoras theorem. So AC squared should be equals to 6 squared plus 8 squared. That gives you the length of AC to be 10. Hence, the displacement is going to be 10 kilometers. And we can see it with an arrow here, 10 kilometers from A to C. That's a direct length from A to C. 10 kilometers is going to be your displacement. Two other quantities that we'll use to define motion are speed and velocity. Speed is the rate of change of distance. The formula for speed is distance upon time. Its units are meters per second. Velocity is the rate of change of displacement. The formula is displacement upon time, and the units are meters per second. At this point, you should note that speed is the rate of change of distance, where if distance is a scalar quantity, the speed will also be a scalar quantity. Velocity is the rate of change of displacement, where displacement is a vector quantity, hence velocity will also be a vector quantity. Our final quantity that we'll use to define motion is acceleration. Well, acceleration is the rate of increase in speed or velocity. Its counterpart, deceleration or retardation, is the rate of decrease in speed or velocity. The formula for acceleration is final velocity minus initial velocity upon time. A is equals to V minus U upon T, which can be rearranged in several different ways. The units for acceleration is meters per second squared. I haven't looked at all 5 quantities, define their formulas and their units. Inshallah, we'll use these quantities in various examples to understand exactly how they are applied. But that's going to be for another video. That's it for today. Inshallah, I'll see you in the next one. Bars out.